Hi, in this video we will see how to solve bigger problems in VPROPEL. So when you are given a bigger problem, first of all you have to spend sufficient time on reading and understanding the problem and then split the problem into smaller modules. Don't try to solve the problem as a whole code or something. So identify the smaller modules in solving the problem. And then what you have to do is you have to write code for the smaller modules so that it can be reused. So after splitting into modules, you have to identify the part of the solution which is similar and you have to write a function and then you have to call it in the places wherever it is required. And then after writing the functions, we have to test the smaller modules whether the function is doing its job properly. For example, if you are writing a function to check whether two strings are having some common characters, some number of, for example, if they have common 3 characters, assume that it is a function. Then you have to check whether that particular function is working properly for all the possible cases. That we have to do, and after confirming that the smaller code is working properly, we have to integrate into and write a bigger code. This is what we will approach to solve a bigger problem. Now to further understand how a bigger problem can be approached, and moreover when you are working on an online judge like VPROPEL, what are all the options that is available to check part of the code, that's what we are going to discuss in the rest of the session. So we are going to take this problem, rook and queen problem, that was given as the practice problem. So let me read the statement of the problem. This is regarding the chess. In the chess you will have a rook coin as well as a queen coin. So you know that rook means it can move vertically and horizontally, and it has to be, otherwise the next possible positions can be on the same row or on the same column. So look at the statement of the problem. Given the position of a rook and a queen in a chessboard, that is a 8x8 board, write an algorithm and subsequent Python code to determine the common positions where both rook and queen can be placed in the next move. Okay, so first thing that we have to know is the next position of all possible position of rook and all possible next position of queen, that we have to find out, and then we have to find out which is common. And also the description says that rook can move through any number of cells, okay, either horizontally or vertically. And when you look at a queen, it can move through any number of cells either horizontally or vertically or diagonally, okay. And how we are going to represent this, each cell in the chessboard will be represented by a two tuple that represents the row and the column. For example, if the current position of the rook is 3, 1, then the next possible move will be either it will be on the same row or on the same column. If you consider on the same column, then 1 is the column of this particular position. So all possible things in the chessboard will be 2, 1, 1, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, excluding 3. All other things will be there. And similarly, where it can be placed horizontally, yes, all the possible positions excluding the current position of the rook. So when you look at it, 3, 2, 3, 3, 3, 4, actually 3, 1 is the position. So apart from 3, 1, all other on the same row will be the next possible position of the rook. And similarly, if you consider a queen, okay, the queen is in the position 5, 3. So what are the next possible positions is, it can be on the same row. So row number is 5. So write down all the possible cells on the row number 5. And when you look at the column, it is 3. So all possible column, okay, column number 3, all possible rows that we will write. And for diagonal, okay, so let us picturize it little bit. So when you look at the rook, you see that if this is the position of the rook, it can move either this horizontally, okay, this is what is the horizontal movement, this is the vertical movement the rook can move or the rook can make. When you look at a queen, see here, it has the same power as that of the rook. It can move either horizontally or vertically or diagonally also. So when you look at diagonally, there are 4 possible movement that it can make along the diagonal. When you look at this one, actually this one is going to be, how I can see this is on the right side of the queen. This is the current position. So this is on the right and up. Okay, so you can say that this is up right. It is going to move in the up vertically and right horizontally. So when you look at this particular thing, it is right but down. It is going to be down. Actually I am seeing the movement and saying this will be up and this will be down, right? And when you look at similarly here, it will be to the left, right? This is to the left and down, right? And when you look at this, it will be up and then left, right? So this is how it will move, and we have to appropriately consider all these 4 cases, right? And when you are going to look at the positions also, this is how the position is going to be in the chessboard, right? From left to right, it's going to be 1 2 3 8, and from when you compare from top to bottom, either you can take this way or you can also take this way. Okay, it is up to us to decide, but we have to fix on to one particular way of the representation. Okay, so this is how the board is going to look like, and these 2 coins will move as we have seen here. So now when you look at the diagonal movement, these are all the possible movements. So for a queen, you have to find out what are all the possible movements, and then you have to take intersection. There is the common cells where they can move. That is what we are going to do. And also the output, how it is wanted, also it is said. Okay, the position must be printed in sorted order, sort by row. When the rows are same, sort by column. This is what is the requirement, and a hint is also given in the problem. Use built-in function to sort the values. Already we know that list and tuples can be sorted. Okay, so we will write the code and see rest of the thing. Okay, so there are built-in functions by which we are going to do. And when you look at the input format, the first line is going to contain the row position of rook, and second one is going to contain the column position of rook. Third line is going to contain row position of queen and column position of queen, right? So this is what is the input format. We can form the tuple and do. Before writing the code, first of all, try to fill what are all the input, output, processing involved, solution. When you are going to think this, actually you will be closer to the solution. The time you spend here will really help you to solve the problem in a quicker manner. Okay, do not directly jump to the code. Do some kind of analysis on this PAC, problem analysis chart. That will help you a lot. Similarly, when you are going to write the algorithm also, you can write specifically, I can say like algorithm for finding common, or you can say positions along same row. Okay, I can write algorithm for this. So you will be given a position P, and you have to find out what are all the positions that are available on the same row. You can write some steps. Okay, in step 1 you can say that this is how it will be, you have to iterate and so on, right? And next you can write an algorithm for finding positions along the same column, right? And then you can write a algorithm for finding which is along the diagonal. You can say there are 4 ways in which it can move. So whatever thought process is required for solving the problem, you put it in plain English, the understanding required for solving the problem. That is what is the algorithm part. Okay, and after writing the algorithm part, you can go to the code, and first you have to write function by function. That is what is required. So we will read the input one by one. So the first input is going to be the row of the rook. Let me say as rook row, and let us read it. It's going to be a integer input. So okay, and then the column of the rook, which is also going to be a integer input, and then queen row, then queen column, and then you can form the tuple, okay, for rook position and for queen position. Let us form the tuple. That will be easy for the representation. So I am going to form a tuple, rook row comma rook column, and similarly for queen position also I am going to say queen row and then queen column. Okay, so the things are ready now, the tuples are ready. Now what we are going to do is I am going to write a function. First of all I am going to write a function for finding out the same row positions. Okay, so for this I am going to pass a position as an input. So when I say a position as an input, it's going to be a tuple, right? So what I will do is I will call this rook, okay, possible positions equal to same row position of rook position. Okay, so rook next possible positions, what is going to be there is, first of all you will find out along the row and then along the column. Okay, so first of all let me write for along the same row. So the input, when you look at it, it's a tuple, okay, and I am going to say what is going to be the row position is P of 0. The first one is going to be the row position, and when you look at the column position, it's going to be the second one. So this is how it's going to be, and I am going to have a list. Okay, so let me call that as a row list, which is a empty list, and so this is the place where I am going to put all the possible row positions of the particular rook. Okay, so how it is going to be is for I in range, let me say the positions are going to be 1 to 8, right? So for I in range 1, 9. Okay, what I am going to do is I am going to find out what is POS. It is on the same row. It's also a tuple now. So I am going to say row comma I. Okay, so when we say same row, then column is going to vary. So this loop is going to be the column. So first it will try 1 and then 2, 3 and so on. I am finding a position and I am checking if position not equal to the P, what is there, then I am going to add it to the row list. Okay, I will say row list dot append of POS, right, and then you return the, you go to the correct thing and you return the row list. So now we have found the positions which are on the same row. Okay, now we have to check whether this code is working properly or not. So what I am going to do is, here is the function call I have made. I am going to print rook possible positions. Okay, let me print it. So now what we will do is we will just check whether it is working properly. So you have to click this one because you are going to give your own input and output and you are going to check. So I am going to give the row position of the rook, let it be 3 and column position be 1. So I consider the position 3, 1 as the rook position and 3, 5 as the queen's position. Okay, if something is there, actually the IP address will be displayed. Please remove that and give only the input what you want to give for the problem, and output you need not give. Actually that is only optional. If you want to just see what is getting printed, then no need to give the output. Now you can execute the code and check. You see that what is returned is except 3, 1, all other positions along the row is returned, isn't it? You can see this. So similarly we have to write the same column position, right? So let us write for that. So when I say same column position, for that also a position will come as the input, and you can similarly take the row and the column, right? Row and the column value we can take, and then we can have a column list. Okay, let me say a column list is there, and then I am going to iterate through, but in this case the column will be fixed because you want to move along the same column. So you will fix the column and you will move the row. Let me say position is equal to, what will be the position is, you want to move the row, so I variable will be the first one because in the tuple first one indicates the row and the second one will be the column which has come, right? And now we are checking if py is not equal to p, right? In that case what you are going to do is you are going to add it to the column list dot append of pys, and then you can return. Okay, so yeah, return column list. Okay, so we will do this, and let us call only the column position now. Okay, so I am going to say row position equal to column position. So call only that function to verify whether this is working properly or not. Now I can use the same input and I can press execute and see what happens. Yeah, I am getting everything on the same column. Actually 3,1 is there. You see that now everything on this column 1 is getting printed except 3,1. This is what I want, right? So now we have got two functions. One is to find the same row thing, and other one is going to find out all positions along the same column, right? So same row position you can say, and so what will be the all possible position of the row is same row, okay, and same column, habitual. So I am pressing Ctrl S, so only that is happening. So same row position, you are passing the row position, same column thing. So this will be the all possible positions of the row. Okay, so for the same input let us execute and see what happens. Yeah, so you are getting a list with all the things. What is being done is you have just put a plus operator. We know that when we put a plus operator, concatenation of the list elements will automatically happen. Okay, so that is done. Next, what is left over is for a queen. For a queen, all possible positions, one is along the same row, that we can use the same function now. See, we have returned the function, given the position, the function will return same row position. So for queen also we can use the same thing. Similarly, same column also we can use the same function what we have returned for the row. Only thing that we have to write is for the diagonal. If we write for the diagonal, if we combine all the three, then it is done. Okay, so let us see how to write for the diagonal. So let us write the function for same diagonal position. For this also a position is going to come as a input, and row is going to be p of 0 and column is going to be p of 1, right? And we are going to have a diagonal list. It's going to be a list of tuples. Once again it's going to be empty, and then what you are going to do is there are 4 ways, as we have seen. There are 4 ways in which you can make the movement. Okay, up right, down right, up left, down left, right? So let me put it as a comment, up left, okay, or I will put up right first. Okay, up right, and then up, or I can say down right, and then up left, and then up down left. Okay, so these are all the 4 ways in which we can move. When you want to move diagonally, these are all the 4 possibilities. So when I say upright, the row is also going to change as well as the column is also going to change. So when we say right, the column is going to increase. So leftmost will be 1 and rightmost will be 8. So when I say I am going to move right, the column value is going to increase, and when I am going to say I am going to move up, the row value is also going to increase, because I am going to consider the lowermost row as 1 and the topmost row as the 8. So I am going to increase both row and the column. But you know very well that when you are going to loop through, when I am going to now write a for loop, right? Let me say for I in, when I say upright, I am going to have this I for controlling the row, okay. So for I in range, okay, when I want to do it for the row, it will be the row plus 1, okay. It has to increase and the stopping value will be 8. So I am giving row plus 1 comma 8, comma 9, because range we know that it will generate value less than the stopping value, and by default the step value is going to be 1. So I am saying row plus 1 comma 9. This is how it's going to increase, but I should also consider the column. Column should also increase. When I say I want to move right, this is for up. When you, row means you are moving up, right, and column means you are going to move right. So I should see the boundary there also. So how I am going to do is, I am just going to have a if and I will break it, okay. So when you write it, you will better get the point. So in this case, both the row and the column should change. So let me have another one variable j representing the position of the column, and since the column is also going to increase along the right, so I am initializing j is equal to column plus 1, and I am checking if j is greater than 8, okay. If it is greater than 8, in that case what I am going to do is, I am just going to break the loop. I should not consider position, okay. That is, either I can reach the dead end by moving rightwards, or I can reach the dead end by moving upwards, right. So this will control the row position, that is upwards, okay. But this will but when I am going to move along the column on the right, I have to have a check. For that only if is there, and I am going to break the loop if the value of j is greater than 8, right. Otherwise what we are going to do is, we are just going to put it inside the diagonal list. So what I will do is, diagonal list dot append, and I have to put it as a tuple. So I comma j, right. This will be the thing what I am going to put inside the diagonal list when I am going to move up right. And also you have to increment the j value, okay. This one also you should do. Next what we are going to consider is down right. So when I say down, okay, what is going to happen is, the row is going to decrease, okay. When we are going to move down, the row value is going to decrease, but the column is going to increase, because we are moving towards the right, okay. So let me say column j is equal to column plus 1 as before, but when you look at the I value, I should start from row minus 1, because you are going to move towards the down direction, okay. So row minus 1, and you will stop when you reach minus 1, okay. You will go you will reach 0 when you reach 0, because we are going to consider the positions from 1 to 8. So when you reach 0, you are going to stop, and step now is going to be minus 1, not 1, right. And similarly you can check here, if j is greater than 8, then you can break the loop, and otherwise you are going to put it inside the diagonal list, okay. You will put I comma j, okay. This is what we will do, and similarly we should not forget to increment the variable also. Let us change the variable, otherwise it will go on an infinite loop. That we should remember. Next we will see how to do up left. So when I say up and left, so when I want to move up, right, the row is going to increase, but when I am going to move left, the column is going to decrease, right. So the j will be column minus 1, and for I in range, okay. So since we are going to move up, it's going to be row plus 1, comma 9, and it's going to increment. Step value is going to be only 1, so we need not include, it's not required, so let us leave as such. Okay, and you are going to check if j is equal to 0. I can check like this. Okay, and j becomes 0, I can break, right? Otherwise what we are going to do is we have to put it in the diagonal list. There is a typo in the previous one. Diagonal list. Okay, diagonal list dot append of I comma j. Okay, and you have to also change the j. Now j will be minus equal to 1. This one you will do, you will decrement, because j is going to be on the left, so it should be decremented. That is column, now it's going to decrease. Okay, okay, so the next one is down left. So when you are going to move down left, both are going to decrement. So let me say j equal to column minus 1 for I in range. Okay, row minus 1, and you will go till 0, and the step value should be minus 1, right? And you are checking here, if j equal to 0, then you are going to break, and otherwise you are going to append the diagonal list. Okay, so let me say comma j, and you should also change the value of the j, right? So after doing this, we have covered all the cases. So you are going to return the diagonal list. Okay, that is what is done. Okay, so after finishing this particular function, what we have to do is we have to find out the queen positions. Okay, now I am going to find the queen positions. First of all, I will check only this particular function. There is same diagonal position. Though I require other things, now I will call only this function to know whether that is working properly or not. So the input for this will be queen position. Okay, the tuple queen position is the input, right? So let me print also and see what is being returned by the function. So let us execute the code and see for the same input what is given in the problem. So the rook position is 3 1, queen position is 5 3. Let us execute the code and check. So see, these are all the diagonal positions returned. I have already copied into a notepad. You can see that 6 4 7 5 8 6 is there, 4 2, yes, 4 2 is here, and 5 1 is also present here, right? And then you can see 6 2, yeah, 6 2 is here, and then 7 1, yeah, all the values, 4 4, yes, 4 4 is here, and then 3 5, yeah, all the values are present. Whatever is required is present over here, right? So the code is fine for finding the diagonal position. You have to verify like this, and then what you have to do is the queen can do the same row also. Okay, so let us put that same row position also for the queen. Okay, and then for the queen you have same column position also, right? So you can do this, and after this what we have to do is we have to find the common position among the rook and the queen. So how we can do that is, it is very simple. In the case of Python we have got this set, right? So what we are going to do is, first of all we are going to convert the queen position into a set, and you do an intersection operation. For intersection we will use ampersand, right? And you convert this also to a set, and again you can convert it to a list. Okay, because I want to print it in the sorted manner, so I am going to do this, right? So this set will be helpful for finding the common elements easily, right? And then what we can do is we can find the you find the sorted order of this and you can print it, right? Yeah. Okay. So after sorting, we are going to print the position one by one. Now let us execute the code and check. You can see that your program output is 3335. Okay. I hope it is almost got. So what you can do is, after confirming this, you can try it for the entire code. Yeah, it is passed, right? So this is how you can approach a bigger problem. So identify the smaller parts and then you prepare functions and you find out where they can be called and so on, and then you can try to solve the problem, right? So that will be helpful for solving a bigger problem. Even if you are not able to solve it, the evaluator will find that you have understood and they will give considerable amount of mark, whatever you deserve. Getting the success message is not important. The process what you are going to follow is more important, particularly when you are going to solve a bigger problem. Thank you.